Tonight, we begin with a question that has captured human imagination for generations, yet finds its most profound answers not in fantasy, but in the quiet elegance of physics itself. Time travel. The very phrase conjures images of spinning machines and glowing portals, but the real story is far more beautiful, far more subtle, and surprisingly, far more real than fiction has ever dared to suggest. So settle in, let the day's tensions fade away, and allow yourself to drift into the gentle current of discovery as we explore what the universe actually tells us about moving through time. Before we venture into the mechanics of temporal flow, take a moment to breathe deeply and consider this simple truth. You are already a time traveler. Right now, as you listen to these words, you're moving through time at the steady rate of 1 second per second, carried forward by the inexorable current of existence itself. But what physics reveals is that this rate, this seemingly constant rhythm of temporal passage, is neither fixed nor universal. It bends, it stretches, it flows like a river that runs at different speeds, depending on where you find yourself in the cosmic landscape. The foundation of our understanding begins with a quiet revolution that occurred in the early 20th century, when a young patent clerk named Albert Einstein gazed into the nature of reality and discovered something extraordinary. Time, he realized, was not the rigid, absolute framework that humanity had assumed for millennia. Instead, it was woven together with space itself into a single, malleable fabric that could be stretched and compressed by motion and gravity. This revelation, gentle as morning light breaking through clouds, would forever change how we understand the possibility of time travel. Einstein's theory of special relativity, published in 1905, rests on two beautifully simple principles that carry profound implications. First, the laws of physics remain the same for all observers moving at constant speeds. Second, the speed of light in a vacuum is constant for all observers, regardless of their motion or the motion of the light source. These seemingly innocent statements lead to a remarkable conclusion that time itself is not absolute, but relative to the observer's frame of reference. Imagine, if you will, two travelers on a cosmic journey. One remains at rest, while the other accelerates to tremendous speeds, approaching the velocity of light itself. To each traveler, their own time passes normally, their own clocks tick at the familiar rhythm they have always known. But something remarkable occurs when they compare their experiences. The high-speed traveler discovers that time has moved differently for them relative to their stationary companion. This is not illusion or trick of perception. It is a fundamental feature of reality itself, measured and confirmed countless times by the most precise instruments humanity has created. This phenomenon, known as time dilation, represents the most scientifically verified form of time travel. It occurs naturally, constantly, all around us, though usually in amounts too small to notice in our everyday experience. Every time you walk across a room, you experience time slightly differently than someone sitting still. Every time you drive in your car, you are traveling through time at a rate marginally different from pedestrians on the sidewalk. The effects are minuscule at everyday speeds, but they are real, and they accumulate in measurable ways. Perhaps the most elegant demonstration of time dilation occurs high above our heads, in the network of satellites that enable our modern navigation systems. These GPS satellites orbit Earth at tremendous speeds, roughly 14,000 kilometers per hour, while simultaneously experiencing weaker gravitational fields than we do on the surface. Both of these factors affect the flow of time in ways that would render GPS useless if engineers did not account for relativistic effects. The satellites experience time at a rate that differs from Earthbound clocks by about 38 microseconds per day. This might seem negligible, but in a system that relies on precise timing to calculate positions, such discrepancies would accumulate into errors of several kilometers within just a single day. The fact that your phone can guide you to your destination with meter-level accuracy is daily proof that time travel, in its forward-moving form, is not only real, but essential to modern technology. Consider the profound implications of this reality. The astronauts aboard the International Space Station, orbiting Earth at over 27,000 kilometers per hour, are literally traveling into our future. When they return to Earth after months in space, they have aged slightly less than those who remained on the ground. The difference amounts to mere milliseconds over the course of a mission, but it represents genuine time travel, a measurable journey into what was once our shared future. This forward time travel becomes even more dramatic as speeds approach the speed of light. A traveller moving at 90% of light speed would experience time at roughly half the rate of a stationary observer. A journey that feels like 1 year to the traveller would correspond to more than 2 years passing on Earth. At 99% of light speed, the effect becomes even more pronounced, with the traveller's year corresponding to more than 7 years of Earth time. As the speed approaches the speed of light itself, time dilation approaches infinity, though reaching light speed remains impossible for objects with mass. This is the twin paradox, a thought experiment that illustrates the asymmetric nature of relativistic time travel. Imagine identical twins, one who embarks on a high-speed journey to a distant star, and another who remains on Earth. When the travelling twin returns, they would find their earthbound sibling has aged significantly more. This is not science fiction, but a direct consequence of the geometry of space-time itself, though the extreme speeds required make such dramatic examples purely theoretical with current technology. But speed is not the only factor that influences the flow of time. Einstein's later work, General Relativity, revealed that gravity itself bends the fabric of space-time, creating what we might think of as valleys and hills in the temporal landscape. Time moves more slowly in stronger gravitational fields, an effect that has been measured with extraordinary precision using atomic clocks at different altitudes. At sea level, where Earth's gravitational pull is strongest, time moves slightly slower than it does at higher elevations. This gravitational time dilation means that a clock placed at the top of a mountain will run faster than an identical clock at the bottom of a valley. The difference is subtle but real, amounting to about 4 parts in a billion per kilometre of altitude. This might seem academic, but it has practical implications for any system requiring precise synchronization across different elevations. The most extreme examples of gravitational time dilation occur near the most massive objects in the universe. Near a black hole, where gravity warps space-time to extraordinary degrees, time can slow to a crawl relative to distant observers. An astronaut falling toward a black hole would experience time normally from their perspective, but to someone watching from a safe distance, the astronaut would appear to slow down dramatically as they approached the event horizon, their image becoming increasingly redshifted and dim until it fades from view entirely. This is forward time travel in its most dramatic form, though it comes with obvious practical limitations. The astronaut falling into the black hole does indeed travel into the future of the outside universe, but they can never return to share their experience. From their perspective, they pass through the event horizon and continue falling, but from the outside universe's perspective, they are frozen at the boundary of the black hole, slowly fading from view as their light becomes infinitely red-shifted. These effects of special and general relativity combine in complex ways throughout the universe. The GPS satellites experience both forms of time dilation simultaneously. Special relativistic effects due to their orbital velocity cause their clocks to run slow relative to Earth, while general relativistic effects due to the weaker gravitational field at their altitude cause their clocks to run fast. The net result is that the general relativistic effect dominates, causing satellite clocks to gain time relative to Earthbound timepieces. Understanding these temporal effects requires us to abandon our intuitive notion of universal, synchronized time. In the universe described by Einstein's theories, there is no single, absolute now that extends across all of space. Instead, simultaneity itself becomes relative to the observer's motion and position in gravitational fields. Events that appear simultaneous to one observer may occur at different times according to another observer in a different reference frame. This relativity of simultaneity has profound implications for our understanding of causality and the nature of time itself. It suggests that the universe is not a stage upon which events unfold in a predetermined sequence, but rather a four-dimensional space-time where past, present, and future coexist as different regions of a single geometric structure. From this perspective, time travel into the future is not so much about moving through time as it is about taking different paths through the fixed geometry of space-time. The mathematical framework of relativity describes these effects with elegant precision. The Lorentz factor, a simple mathematical expression involving velocity and the speed of light, quantifies the degree of time dilation for any given speed. Similarly, the gravitational redshift formula describes how time flows at different rates in varying gravitational fields. These are not approximations or theoretical constructs, but exact relationships that govern the behavior of time throughout the universe. As we've seen, forward time travel is not only possible, but inevitable. Every moment of every day, we are all traveling into the future at our own individual rates, determined by our motion and our position in Earth's gravitational field. The effects are usually too small to notice in daily life, but they accumulate over time and become significant for high-precision applications like GPS navigation or particle physics experiments. But what about traveling backward in time? Can we journey into the past as easily as we voyage into the future? This question leads us into more speculative territory, where the solid ground of experimental verification gives way to theoretical possibilities that push the boundaries of known physics. The answers we find are both fascinating and sobering, revealing the deep connections between causality, paradox, and the fundamental structure of reality itself. The mathematical formalism of general relativity does, in principle, allow for certain exotic space-time geometries that could permit travel into the past. These solutions to Einstein's equations describe universes with properties very different from our own, where the normal relationship between cause and effect becomes entangled in ways that challenge our deepest assumptions about the nature of time and reality. The most tantalizing aspect of general relativity's mathematical landscape lies in its description of closed time-like curves, pathways through space-time that loop back upon themselves, theoretically allowing an object to return to its own past. These mathematical solutions exist within Einstein's equations, like hidden chambers in an ancient palace, accessible through calculation but separated from reality by seemingly insurmountable barriers. The first and most famous of these theoretical constructs emerged from the brilliant mind of Kurt Gödel in 1949. Gödel, better known for his incompleteness theorems in mathematics, discovered a solution to Einstein's equations that describes a rotating universe. In this strange cosmos, the entire fabric of space-time spins like a vast cosmic carousel, dragging time itself along in its rotation. Within such a universe, an observer could theoretically follow a path that brings them back to their own past, meeting themselves at an earlier moment. Picture, if you will, standing on a slowly spinning platform while walking in a careful pattern. With the right combination of your movement and the platform's rotation, you might find yourself returning to the exact spot where you began, but at an earlier time according to the platform's reference frame. Gödel's universe operates on this principle, but with the entire cosmos as the spinning platform and the laws of physics providing the choreography. Yet this elegant mathematical solution comes with a profound limitation. Our actual universe shows no evidence of the global rotation that Gödel's model requires. Careful observations of distant galaxies, the cosmic microwave background radiation, and the large-scale structure of space reveal a universe that expands uniformly in all directions, without any detectable spin. The rotation required for Gödel's time travel would be so pronounced that it would leave unmistakable signatures in the cosmos around us. Signatures that simply are not there. This absence of cosmic rotation suggests that while Gödel's solution is mathematically valid, it describes a universe fundamentally different from our own. It stands as a beautiful theoretical possibility, a road not taken in the cosmic landscape, but not the road we actually travel. The mathematics whisper of what could be, while observation tells us what is. Another intriguing theoretical pathway to the past involves the work of physicist Frank Tipler, who in 1974 proposed what has become known as the Tipler cylinder. Imagine an infinitely long, incredibly dense cylinder spinning at tremendous speed around its axis. The rotation would be so rapid and the mass so great that the very geometry of space-time around the cylinder would twist and distort, creating regions where the light cones of physics tip backward along the time axis. In the language of relativity, light cones represent the boundaries of cause and effect, the limits within which events can influence one another. When these cones tip backward due to the extreme frame-dragging effect of the rotating cylinder, they create corridors through space-time where motion backward in time becomes theoretically possible. A spacecraft following the right trajectory around such a cylinder could, in principle, emerge at a point in space-time earlier than when it began its journey. The requirements for constructing a Tipler cylinder reveal why it remains purely theoretical. The cylinder would need the mass of at least 10 of our suns, compressed into a structure denser than atomic nuclei and spinning at a significant fraction of the speed of light. The engineering challenges alone place such a construction far beyond any conceivable technology, but more fundamentally, the extreme conditions required would likely trigger other physical effects that could prevent the formation of closed time-like curves. Stephen Hawking demonstrated that any attempt to build a time machine within a finite region of space-time would require exotic matter with negative energy density, a form of matter that exists only in microscopic quantities in quantum mechanical effects like the Casimir force between conducting plates. The universe seems to have built-in protections against large-scale violations of causality, what Hawking playfully termed the chronology protection conjecture. These theoretical time machines lead us inevitably to confront the logical paradoxes that backward time travel would create. The most famous of these is the grandfather paradox, a scenario where a time traveler journeys to the past and prevents their own birth by interfering with their ancestors. If successful, the traveler would never have been born to make the journey in the first place, creating a logical contradiction that seems to tear at the fabric of cause and effect itself. Consider the gentle absurdity of this situation. The very success of the mission to change the past would eliminate the motivation and possibility for the mission to occur. It is as if a river could flow backward and erase the spring from which it originated, leaving no source for its own existence. Such paradoxes suggest that either backward time travel is impossible, or that the nature of causality is far more subtle than our everyday experience suggests. The bootstrap paradox presents another puzzle for the logical consistency of time travel. Imagine a scenario where information or an object appears to exist in a closed causal loop with no discernible origin. A book of poetry travels back in time and inspires its own creation, or a piece of technology is sent to the past where it is studied and eventually developed, only to be sent back again. Where did the information originally come from? What was the first cause in a chain of effects that loops back upon itself? These paradoxes have led some physicists to explore whether quantum mechanics might provide resolution through its inherently probabilistic nature. David Deutsch proposed in 1991 that quantum superposition could allow particles to exist in multiple states simultaneously while traversing closed time-like curves, potentially avoiding the stark contradictions of classical paradoxes. In this quantum mechanical approach, a time traveler might exist in a superposition of states where they both do and do not interfere with their own past, with the probabilities adjusting to maintain consistency. Yet even these quantum mechanical solutions require exotic physics that pushes the boundaries of what we consider possible. The consensus among physicists remains that while the mathematics of general relativity permits certain forms of backward time travel, the physical requirements are so extreme and the logical complications so severe that such travel remains firmly in the realm of theoretical speculation rather than practical possibility. The search for backward time travel has also led to investigations of wormholes, theoretical tunnels through space-time that could connect distant regions of the universe. These Einstein-Rosen bridges, as they are formally known, arise naturally from certain solutions to the equations of general relativity. If such structures existed and remained stable, they might provide shortcuts, not only through space, but potentially through time as well. The challenge with wormholes lies in their stability. The natural tendency of these space-time tunnels is to collapse almost instantly upon formation, pinching off any connection between their entrance and exit. Keeping a wormhole open would require threading it with exotic matter possessing negative energy density, the same mysterious substance needed for most theoretical time machines. This exotic matter would need to violate what physicists call the averaged null energy condition, pushing against fundamental principles that govern the behavior of energy and matter throughout the universe. The Casimir effect provides the only experimentally verified example of negative energy density occurring between closely spaced conducting plates in a vacuum where quantum fluctuations create a region with less energy than empty space itself. However, the quantities involved are vanishingly small, and no known mechanism could scale such effects to the macroscopic level required for stabilizing traversable wormholes. The universe appears to be remarkably conservative about allowing violations of energy conditions on large scales. Miguel Alcubierre's 1994 proposal for a warp drive represents another theoretical approach to faster-than-light travel that could have implications for time travel. The Alcubierre drive would work by contracting space-time in front of a spacecraft while expanding it behind, creating a bubble of flat space-time that could theoretically move faster than light without violating relativity within the bubble itself. The spacecraft would remain stationary within its local region of flat space-time, while the bubble carrying it moves at superluminal speeds. Like other exotic propulsion concepts, the Alcubierre drive requires negative energy density to function, with energy requirements that initially appear to exceed the mass energy of the observable universe. Subsequent refinements have reduced these requirements somewhat, but they remain far beyond any conceivable technology. More troubling for causality, faster-than-light travel of any kind opens the possibility of closed time-like curves, allowing messages or travelers to arrive before they departed, according to certain reference frames. These theoretical constructs share a common theme. They exist as valid solutions to the equations of physics, mathematical possibilities that reveal the rich structure of space-time geometry, yet they require physical conditions so extreme or exotic that they remain disconnected from observable reality. They serve as probes into the fundamental nature of time and causality, showing us the boundaries of what physics allows, while simultaneously demonstrating why those boundaries are rarely approached in the actual universe. The absence of time travelers from the future provides another line of evidence against the practical possibility of backward time travel. Stephen Hawking once hosted a party for time travelers, sending out invitations only after the party had ended. No guests from the future appeared, leading Hawking to conclude somewhat tongue-in-cheek that time travel is not possible, or at least that future civilizations are remarkably polite about not interfering with the past. More seriously, the absence of any verified temporal paradoxes or causality violations in our experience suggests that if backward time travel is possible, it operates under constraints so strict that its effects are effectively invisible. The universe maintains a remarkable consistency in its causal structure, with effects following causes in orderly sequence throughout all observed phenomena. As we explore these theoretical possibilities, we must remember that physics is ultimately an empirical science grounded in observation and experiment. While mathematics can guide us toward possible worlds and reveal the hidden structures of reality, It is observation that tells us which possibilities are actualized in our universe. The mathematical elegance of closed time-like curves and exotic space-time geometries speaks to the rich theoretical framework of general relativity. But the absence of exotic matter and the stability of causality in our observed universe suggests that forward time travel remains the only form accessible to us. This forward journey through time, however, is far from limiting. Every moment carries us deeper into the future, and the rate of that journey can be influenced by our motion and our position in gravitational fields. We are all time travelers, riding the current of temporal flow at our own individual rates, shaped by the physics of relativity in ways both subtle and profound. The deeper we venture into these concepts, the more we realize that time travel is not about escaping the present moment, but about understanding the true nature of time itself. Rather than seeking to violate causality or reverse the arrow of time, physics invites us to appreciate the elegant ways that time, space, motion, and gravity interweave to create the rich tapestry of temporal experience. In our everyday lives, we experience time as a steady river flowing in one direction, carrying us from past toward future at the comfortable rate of 1 second per second. But physics reveals this river to be more like a vast network of streams, each flowing at slightly different rates depending on the motion and gravitational environment of the observer. The GPS satellites overhead experience time at a different rate than we do on Earth's surface. Airline passengers travel through time slightly differently than ground-based observers. Even the simple act of climbing a staircase carries us into a region where time flows at a marginally different pace. These effects accumulate in ways that connect us to the cosmic scale of space and time. The astronauts aboard the International Space Station return to Earth having aged microseconds less than their Earthbound counterparts, genuine time travelers who have journeyed slightly into our common future. High-energy cosmic ray particles racing through space at near-light speeds experience time dilation so extreme that unstable particles with lifetimes measured in microseconds can traverse entire galaxies before decaying. The universe itself participates in this temporal dance through its expansion and evolution. Distant galaxies appear to us as they were billions of years ago, their light carrying information from the deep past across the expanding fabric of space-time. We observe the universe not as it is now, but as it was at various times throughout its history, creating a kind of time travel through observation itself. When we gaze at stars, we see into the past, receiving photons that began their journey years, decades, or centuries ago. This cosmic perspective on time reveals something profound about our relationship with the temporal dimension. We often think of ourselves as passive passengers carried along by time's current, but physics shows us that we are active participants in shaping our journey through the fourth dimension. Every choice we make about motion, every step we take, every flight we board, subtly alters our path through space-time and influences the rate at which we experience the passage of time. The beauty of this realization lies in its universality. Whether you are reading quietly in your living room or traveling across continents, whether you are standing at sea level or hiking in the mountains, you are engaged in a delicate dance with time itself. The differences may be measured in nanoseconds or microseconds, barely perceptible to human senses, but they represent genuine variations in the fundamental experience of temporal flow. Consider the profound implications of this for our understanding of simultaneity across the cosmos. When we say that an event happened now on a distant star, we must ask ourselves what now actually means in a universe where time flows at different rates for different observers. The concept of a universal present moment, synchronized across all of space, dissolves under careful examination. Instead, we find that the universe presents us with a rich tapestry of interwoven timelines, each valid from its own perspective, each contributing to the magnificent complexity of space-time geometry. This relativity of simultaneity extends far beyond abstract mathematical concepts. It touches the very heart of how we understand cause and effect throughout the cosmos. Two events that appear simultaneous to an observer on Earth may occur at distinctly different times, according to an observer traveling at high speed relative to our planet. The sequence of cause and effect itself can appear different to observers in relative motion, though the causal structure of space-time ensures that no observer ever witnesses an effect preceding its cause in their local reference frame. The implications cascade through our understanding of cosmic evolution and the flow of information across vast distances. When we observe the light from a distant supernova, we witness an event that occurred years or centuries ago, according to our earthbound reference frame, but from the perspective of a high-speed cosmic ray particle traveling from that same stellar explosion, the journey to Earth might unfold in mere moments due to extreme time dilation effects. The universe maintains perfect consistency in its causal structure while allowing for dramatically different temporal experiences. This brings us to contemplate the nature of time itself on the largest scales. The expansion of the universe provides another profound example of how cosmic motion influences temporal experience. As space itself stretches between distant galaxies, carrying them apart at velocities that can exceed the speed of light, the cosmic expansion creates a natural framework for understanding time on universal scales. The cosmic microwave background radiation provides a kind of universal clock, a relic of the early universe that defines a preferred reference frame for measuring cosmic time. Yet even this cosmic time is not absolute. Observers moving at high speeds relative to the cosmic microwave background would measure different rates of cosmic expansion and would disagree about the precise age of the universe. The 13.8 billion years we quote as the universe's age applies specifically to observers at rest relative to the cosmic background radiation. Other observers, moving through space at different velocities, would calculate slightly different values, while remaining perfectly correct within their own reference frames. The cosmic perspective also reveals how gravity shapes time on the grandest scales. The distribution of matter throughout the universe creates a complex landscape of gravitational time dilation, with time flowing at different rates in different regions of space. Near massive galaxy clusters, where dark matter and ordinary matter combine to create deep gravitational wells, time moves more slowly relative to the sparse regions between galactic superclusters. This gravitational time dilation affects not only the flow of time, but also the redshift of light traveling between different regions of the cosmos. Black holes represent the most extreme examples of gravitational time dilation in our universe. These cosmic laboratories of extreme physics push the effects of general relativity to their limits, creating regions where the curvature of space-time becomes so severe that time itself nearly stops relative to distant observers. The event horizon of a black hole marks the boundary where gravitational time dilation becomes infinite from the perspective of outside observers, creating a temporal barrier beyond which information cannot escape. The physics near black holes reveals fascinating connections between gravity, time, and information. As matter falls toward a black hole, it experiences increasingly severe time dilation. From the perspective of the falling matter, time continues to flow normally, and the journey through the event horizon feels unremarkable. But to outside observers, the falling matter appears to slow down dramatically as it approaches the event horizon, its image becoming increasingly red-shifted and dim until it fades from view entirely. This apparent contradiction resolves through careful consideration of reference frames and the finite speed of light. The falling observer experiences normal time flow and passes through the event horizon in finite proper time. The outside observer never sees this crossing occur because the light signals carrying that information become infinitely redshifted and delayed. Both perspectives are correct within their respective reference frames, illustrating the subtle but profound ways that relativity reconciles seemingly contradictory observations. The study of black holes has also revealed deep connections between gravity, thermodynamics, and information theory that may hold keys to understanding time on quantum scales. Black holes possess temperature and entropy, radiating energy through Hawking radiation, in a process that slowly evaporates these cosmic monsters over vast timescales. This evaporation process raises profound questions about the nature of information and its relationship to time, leading to ongoing research into the black hole information paradox and its implications for quantum gravity. These extreme environments push our understanding of time to its limits and reveal the boundaries where classical general relativity must eventually give way to a more complete theory of quantum gravity. The Planck scale, where quantum effects become comparable to gravitational effects, represents a frontier where our current understanding of space-time itself may break down. At these microscopic scales, time may not exist as the smooth, continuous dimension described by classical relativity, but might instead emerge from more fundamental quantum processes. Quantum mechanics introduces its own subtle relationship with time through the uncertainty principle and the probabilistic nature of quantum measurements. While quantum mechanics assumes a fixed background of absolute time for its mathematical formulation, the measurement process itself involves temporal sequences that raise deep questions about the nature of causality and temporal order in quantum systems. The quantum Zeno effect demonstrates how the act of observation can slow or even halt the evolution of quantum systems, creating another subtle form of temporal manipulation at microscopic scales. The intersection of quantum mechanics with general relativity and theories of quantum gravity may ultimately reveal that time itself is not fundamental, but rather emerges from more basic quantum processes. Some theoretical approaches suggest that space-time, including the temporal dimension, might arise from entanglement patterns in quantum information, or from the collective behavior of microscopic quantum degrees of freedom that exist outside conventional space-time. These speculative ideas remain at the frontiers of theoretical physics, far from experimental verification, but they remind us that our current understanding of time may represent only an intermediate step toward a deeper truth about the nature of temporal reality. Just as Einstein's relativity revealed the limitations of Newton's absolute time, future discoveries may reveal new layers of temporal structure that we cannot yet imagine. For now, we can rest comfortably in the established understanding that forward time travel through relativistic effects represents the only scientifically verified form of temporal displacement. This forward journey carries us naturally through the cosmic expansion, through the subtle variations in gravitational time dilation across Earth's surface, and through the gentle time dilation effects of our daily motion through space. Every heartbeat carries us forward through time at our own individual rate, determined by our motion and position in the gravitational landscape of space-time. The practical applications of time dilation continue to expand as our technology becomes more sophisticated and our measurements more precise. Atomic clocks now achieve precision levels where relativistic effects become measurable over short distances and brief time intervals. These instruments can detect the gravitational time dilation caused by elevation changes of mere centimeters, opening new possibilities for geodesy, geology, and fundamental physics research. The global positioning system remains the most widespread practical application of relativistic time effects, but it is far from the only one. Particle accelerators rely on relativistic calculations to predict the behavior of high-energy particles, whose lifetimes are extended by time dilation as they race around accelerator rings at near-light speeds. Astronomical observations must account for relativistic effects when studying high-energy phenomena like pulsars, which are rotating neutron stars, whose precisely timed radio pulses provide natural laboratories for testing general relativity. The study of cosmic rays provides another window into extreme relativistic effects. These high-energy particles from deep space travel at speeds so close to the speed of light that they experience dramatic time dilation during their journeys through the galaxy. Unstable particles that would normally decay in microseconds can survive for millions of years of travel time as measured by Earth-based observers, allowing them to traverse the entire galaxy before finally decaying in Earth's atmosphere. These cosmic messengers carry information about the most energetic processes in the universe, from supernova explosions to active galactic nuclei powered by supermassive black holes. Their ability to survive intergalactic journeys depends entirely on relativistic time dilation, which slows their internal clocks relative to the cosmic reference frame. Without this effect, the highest energy cosmic rays would decay long before reaching Earth, depriving us of crucial information about the extreme physics of the distant universe. The detection and study of gravitational waves has opened yet another window into relativistic physics and its relationship with time. When massive objects like black holes or neutron stars spiral into each other, they create ripples in space-time itself that propagate outward at the speed of light. These gravitational waves carry information about the extreme gravitational fields and relativistic motions present during cosmic catastrophes, providing direct evidence for the dynamic nature of spacetime predicted by general relativity. The precise timing required for gravitational wave detection depends critically on understanding relativistic effects. The laser interferometers that detect these waves must account for the motion of Earth through space, the gravitational time dilation caused by Earth's gravity, and even the tiny relativistic effects caused by the motion of the detection apparatus itself. The successful detection of gravitational waves represents a triumph not only of experimental technique, but also of our understanding of relativistic physics and its effects on the measurement of space and time. As we contemplate these cosmic perspectives on time and motion, we begin to appreciate the elegant unity underlying the apparent diversity of temporal phenomena. From the microscopic world of quantum mechanics to the cosmic scales of universal expansion, from the gentle time dilation of everyday motion to the extreme effects near black holes, all temporal phenomena emerge from the same fundamental principles encoded in the geometry of space-time. This unity suggests that time is not merely a background against which physical processes unfold, but rather an integral aspect of the physical fabric of reality itself. Time and space are woven together into a single geometric structure that responds dynamically to the presence of matter and energy. Motion through this space-time geometry creates the temporal effects we observe, from the simple passage of everyday experience to the exotic possibilities explored in theoretical physics. The philosophical implications of this understanding extend far beyond the technical details of relativistic calculations. If time is indeed relative and malleable rather than absolute and fixed, what does this mean for our concepts of permanence, change, and the nature of existence itself? The relativistic universe presents us with a reality where the past, present, and future coexist as different regions of a four-dimensional geometric structure, challenging our intuitive notions of temporal flow and becoming. Yet rather than diminishing the significance of temporal experience, this relativistic perspective enriches our appreciation for the subtle ways that consciousness navigates the landscape of space-time. Each moment of awareness represents a unique perspective on the four-dimensional structure of reality, a particular vantage point from which the geometric relationships of events reveal themselves through the subjective experience of temporal flow. The meditation-like quality of deep physics contemplation emerges naturally from this perspective. As we quiet our minds and allow the mathematical beauty of relativistic space-time to unfold in consciousness, we participate in a kind of cosmic awareness that transcends ordinary temporal experience. The equations of general relativity become not merely technical tools, but gateways to appreciating the profound unity underlying the apparent multiplicity of physical phenomena. This contemplative approach to physics reveals connections between scientific understanding and timeless wisdom, traditions that have long recognized the illusory nature of conventional temporal experience. While science and contemplative practice employ different methods and languages, both point toward a reality that transcends the ordinary categories of past, present, and future. The relativistic universe of modern physics resonates with ancient insights about the interconnectedness of all phenomena and the relative nature of ordinary experience. As we allow these ideas to settle gently into consciousness, like sediments slowly clarifying a still pond, we can appreciate how the scientific study of time ultimately returns us to the present moment with renewed wonder and appreciation. The complex mathematics of relativistic space-time, the exotic theoretical possibilities of closed time-like curves, and the practical applications of GPS satellites all point toward a single, simple truth. This moment, here and now, represents our only direct access to the temporal dimension of reality. The forward flow of time that carries us from moment to moment operates according to physical principles of extraordinary elegance and universality. Whether we understand these principles in mathematical detail or simply appreciate them through metaphor and intuition, they remind us that we are integral participants in the cosmic dance of space-time geometry. Our consciousness rides the gentle current of temporal flow, shaped by our motion through space and our position in Earth's gravitational field, connected through invisible threads of relativity to every other conscious being sharing this moment in the cosmic expansion. This recognition brings a profound sense of peace and connection. The time dilation effects that make GPS navigation possible also connect us to astronauts orbiting overhead, to cosmic ray particles racing through the galaxy, and to the grand expansion of the universe itself. We are not isolated observers watching time pass from the outside, but intimate participants in the fundamental processes that create temporal experience throughout the cosmos. The gentle nature of these effects in everyday life provides reassurance rather than anxiety. The relativistic universe does not threaten our ordinary experience, but rather enriches it with deeper meaning and connection. The coffee cooling on your bedside table, the breath entering and leaving your lungs, the subtle settling of your body into comfortable rest. All of these everyday phenomena participate in the cosmic dance of space-time, connected through relativity to the largest structures and longest timescales in the universe. As consciousness begins to settle into the natural rhythm of rest, we can appreciate how the physics of time ultimately supports, rather than contradicts, our deepest intuitions about temporal experience. The forward flow of time, the irreversibility of aging and change, the way memory preserves the past, while anticipation reaches toward the future, all of these familiar aspects of temporal life find their scientific foundation in the thermodynamic arrow of time and the cosmic expansion that provides the backdrop for all temporal experience. The theoretical possibilities for backward time travel, with their exotic requirements and logical paradoxes, serve primarily to highlight the remarkable stability and consistency of forward temporal flow. The universe appears to be constructed in such a way that causality remains inviolate, that effects follow causes in orderly sequence, and that the arrow of time points steadily toward increasing entropy and cosmic expansion. This stability provides the foundation for consciousness itself, allowing memory, planning, and the entire architecture of temporal awareness to develop within the protective boundaries of consistent causal structure. In this light, the absence of practical backward time travel emerges not as a limitation, but as a feature of cosmic design that makes complex temporal experience possible. A universe filled with causal loops and temporal paradoxes would be incompatible with the delicate information processing that underlies consciousness and memory. The forward-only nature of practical time travel preserves the logical structure within which awareness can unfold, grow, and develop across the lifespan of conscious beings. This understanding brings profound comfort as we prepare for rest and renewal. The time that carries us through sleep and dreams operates according to the same elegant principles that govern cosmic expansion and stellar evolution. The hours that pass while consciousness rests participate in the same relativistic framework that connects Earth's surface to orbiting satellites, that links our local gravitational field to distant black holes, and that weaves our individual temporal experience into the grand tapestry of cosmic time. The gentle tick of bedside clocks marks not merely the passage of arbitrary units, but the fundamental rhythm of space-time itself, the steady progression through four-dimensional geometry that carries all of consciousness forward into tomorrow's possibilities. Each second that passes represents a tiny step along the cosmic journey that began with the Big Bang and continues through the ongoing expansion of space and time. Sleep itself becomes a form of time travel, a natural process that carries consciousness forward through the night toward the renewal of another day. The dreams that may visit during rest participate in the same temporal framework as waking experience, unfolding within the protective embrace of forward-flowing time, while memory weaves together past and present into the fabric of continuous identity. As the gentle current of temporal flow carries you toward rest, remember that this movement through time connects you to everything that has ever been and everything that ever will be. The same space-time geometry that allows stars to be born and galaxies to evolve also cradles your consciousness as it settles into the peaceful rhythm of sleep. You are not separate from the cosmic dance of time and space, but intimately woven into its unfolding patterns, carried forward by forces of elegant mathematical beauty that operate with perfect consistency from the quantum scale to the cosmic horizon. The forward journey through time that began at your birth continues now through this moment of rest, will carry you gently through the night, and will deliver you safely to tomorrow's awakening. This is the only time travel that consciousness requires. The steady, reliable, comforting progression from moment to moment that allows life to unfold, grow, and flourish within the vast and beautiful architecture of relativistic space-time. Let yourself rest now in the knowledge that time itself holds you securely, that the same forces that govern the motion of planets and the expansion of the universe also cradle your sleeping consciousness with infinite gentleness. The mathematics of relativity, for all their sophistication and elegance, ultimately serve to describe the cosmic tenderness that carries all beings forward through the dimension of time, moment by precious moment, breath by peaceful breath, toward the quiet mysteries that await in tomorrow's light. The profound beauty of these relativistic effects becomes even more apparent when we consider how they manifest in the everyday world around us. Every person walking down a sidewalk, every bird in flight, every leaf drifting on an autumn breeze experiences time at a slightly different rate than everything else around them. These differences are vanishingly small, measured in fractions of nanoseconds, but they represent genuine variations in the fundamental flow of temporal experience. Consider the gentle motion of clouds drifting overhead, those water droplets suspended in the atmosphere, carried by wind currents at perhaps 20 or 30 kilometers per hour, experience time at a rate minutely different from the trees below. The difference is so small that no clock could measure it, no consciousness could perceive it, yet it exists as a real feature of the physical universe. Each cloud droplet follows its own unique path through space-time, its own individual timeline slightly offset from all the others. This microscopic diversity of temporal experience extends to every scale of natural phenomena. The sap flowing slowly up through tree trunks experiences time differently than the bark surrounding it. Water flowing in streams moves through time at rates that vary with the speed of the current. Even the air molecules in the room around you, dancing in their constant thermal motion, each follow slightly different temporal trajectories as they bounce and collide in their random walk through space. The remarkable fact is that despite this infinite diversity of individual timelines, the universe maintains perfect consistency in its physical laws. Every atom, every molecule, every particle experiences the same fundamental relationships between cause and effect, even though each exists in its own subtly unique temporal reference frame. The laws of physics remain constant across all these individual perspectives, creating a unified framework within which countless different temporal experiences can coexist harmoniously. This universality of physical law provides the foundation for the deeper understanding of time that emerges from quantum mechanics. At the smallest scales of reality, where individual particles dance their quantum ballet, time takes on yet another layer of subtlety. Quantum systems exist in superpositions of states, probability clouds that encompass multiple possible futures simultaneously until the moment of measurement collapses them into definite outcomes. The quantum world reveals that even our most basic assumptions about temporal sequence become fluid at microscopic scales. Quantum particles can exist in states where they simultaneously have and have not yet undergone certain transitions. They can tunnel through barriers, appearing on the other side without ever crossing the intervening space, in processes that challenge our classical understanding of temporal causation. Yet even in this strange quantum realm, the forward arrow of time remains inviolate. Quantum processes may be probabilistic rather than deterministic, but they still unfold according to equations that respect the fundamental asymmetry between past and future. The quantum mechanical description of time evolution, governed by the Schrödinger equation, maintains the same directional flow that characterizes time at larger scales. The intersection of quantum mechanics with general relativity continues to puzzle physicists and may hold keys to an even deeper understanding of temporal reality. Some theoretical approaches suggest that space-time itself, including the dimension of time, might emerge from more fundamental quantum processes. In this view, the smooth, continuous time of classical physics would be an approximation that becomes accurate only at scales much larger than the quantum realm. These ideas remain highly speculative, existing at the very frontiers of theoretical physics, where mathematics probes regions far beyond current experimental verification. Yet they remind us that our current understanding of time, sophisticated as it is, may represent only an intermediate step toward an even more comprehensive view of temporal reality. For our purposes tonight, we can rest comfortably in the established understanding that provides such elegant explanations for the temporal phenomena we observe. The relativistic framework developed by Einstein continues to pass every experimental test with remarkable precision, from the microscopic world of particle accelerators to the cosmic scales of gravitational wave astronomy. The beauty of this framework lies not only in its predictive power, but in the way it unifies seemingly disparate phenomena under a single geometric understanding. The time dilation experienced by GPS satellites, the gravitational redshift of light climbing out of deep gravitational wells, the precise timing of pulsar signals, and the detection of gravitational waves all emerge from the same fundamental insight about the nature of space-time geometry. This geometric view of space-time reveals time to be not merely a backdrop against which events unfold, but an active participant in physical processes. Time responds to the presence of matter and energy, curving and flowing in ways that create the rich tapestry of temporal experience we observe throughout the universe. From this perspective, consciousness itself becomes a kind of exploration of space-time geometry, a way that the universe comes to know its own temporal structure through the subjective experience of aware beings. The contemplation of these deep connections between consciousness and cosmic structure brings a profound sense of peace and belonging. We are not accidental observers peering into a universe foreign to our nature, but integral expressions of the same physical principles that govern stellar evolution and galactic dynamics. The neural processes that create temporal awareness operate according to the same fundamental laws that determine the orbits of planets and the life cycles of stars. This recognition dissolves the artificial boundary between inner experience and outer cosmos, revealing consciousness and universe to be aspects of a single integrated reality. The time that flows through awareness is the same time that carries galaxies apart in the cosmic expansion, that governs the fusion processes in stellar cores, that determines the decay rates of radioactive elements throughout space. As we settle deeper into this understanding, the ordinary concerns and anxieties of daily life begin to take on a different quality. The passage of time, which so often feels like a threat or limitation in ordinary consciousness, reveals itself to be the very medium through which life expresses its deepest creativity and growth. Every moment that passes creates new possibilities, new configurations of matter and energy, new opportunities for complexity and beauty to emerge. The irreversibility of time, which can seem like a source of loss and limitation, actually provides the foundation for all the richness and diversity we observe in the universe. Without the steady forward flow of temporal experience, there could be no evolution, no learning, no growth, no development of the intricate structures that make consciousness itself possible. The cosmic expansion that carries distant galaxies away from us at ever-increasing speeds also creates the stable framework within which stars can form, planets can develop, and life can flourish. The same thermodynamic processes that ensure time's arrow points steadily forward also drive the chemical reactions in living cells, the formation of complex molecules, and the information processing that underlies thought and memory. From this perspective, aging itself becomes not merely a limitation to be endured, but a participation in the fundamental creative processes of the universe. Each day of life represents a unique exploration of the possibilities inherent in conscious existence, a contribution to the universe's ongoing project of understanding itself through the experience of aware beings. The wrinkles that form on aging skin follow the same physical principles that create the complex structures we observe in cosmic gas clouds. The slowing of reflexes with age mirrors the gradual cooling and expansion of the universe itself. The accumulation of memories over a lifetime parallels the way galaxies accumulate stars and stellar remnants over cosmic time. These parallels are not mere poetic metaphors, but reflect the deep unity of physical law that connects all scales of natural phenomena. The same forces that shape the evolution of the cosmos also determine the development and aging of individual organisms. We are not separate from the cosmic story, but intimate participants in its ongoing unfoldment. This understanding brings a gentle acceptance of temporal change that extends far beyond mere intellectual comprehension. When we truly grasp our deep connection to cosmic processes, the natural changes that occur with the passage of time cease to feel like impositions from outside and reveal themselves to be expressions of the same creative force that builds galaxies and ignites stars. The sleep that approaches now participates in these same cosmic rhythms. The circadian cycles that regulate rest and activity in living beings reflect the fundamental periodicities that characterize natural systems at every scale. From the quantum oscillations that define atomic clocks to the orbital periods of planets and the rotation of galaxies, the universe expresses itself through cycles of activity and rest, expansion and contraction, complexity and simplification. Human sleep represents a beautiful example of how biological systems have evolved to harmonize with these cosmic rhythms. The brain waves that characterize different stages of sleep follow patterns that mirror the oscillations found throughout natural systems. The dreams that may visit during rest unfold according to the same principles of temporal sequence that govern all physical processes, creating narratives that connect past experiences with future possibilities. The healing and restoration that occur during sleep operate through the same fundamental forces that drive stellar nucleosynthesis and planetary formation. Cellular repair processes follow chemical pathways determined by the same physical laws that govern the fusion reactions in stellar cores. The consolidation of memories during sleep mirrors the way galaxies form structure through the gradual aggregation of matter over cosmic time. As consciousness prepares to release its grip on ordinary awareness and surrender to the natural rhythms of rest, these connections become particularly poignant. The transition into sleep represents a daily return to the deeper patterns that connect individual existence to cosmic processes. In letting go of the detailed concerns of waking life, consciousness opens to the broader currents that carry all beings forward through time. The darkness that accompanies sleep mirrors the vast, dark spaces between stars, the cosmic voids that provide the framework within which galaxies can form and evolve. Just as these dark regions are not empty, but filled with the subtle influences of dark matter and dark energy, the apparent emptiness of sleep consciousness contains the deeper processes of restoration and renewal that make waking life possible. The silence that settles over the sleeping mind reflects the profound quiet of interstellar space, where sound cannot travel, but where electromagnetic waves carry information across vast distances at the speed of light. In sleep, consciousness becomes receptive to subtler forms of information processing, patterns of neural activity that operate below the threshold of ordinary awareness, but that contribute to the ongoing development of memory, insight, and understanding. The stillness of the sleeping body parallels the apparent motionlessness of distant stars, which seem fixed in their positions, but are actually racing through space at tremendous velocities as part of the galaxy's rotation. Similarly, the resting consciousness continues its journey through space-time, carried forward by the same forces that govern all cosmic motion, participating in the universal expansion while appearing to be at complete rest. These parallels remind us that rest is not a withdrawal from cosmic activity, but a different mode of participation in the ongoing creative processes of the universe. Sleep consciousness explores regions of possibility that remain closed to ordinary waking awareness, following pathways through the landscape of potential experience that contribute to the overall richness and complexity of conscious existence. The dreams that may arise during sleep operate according to their own temporal logic, creating narratives that can compress lifetimes into moments or stretch seconds into apparent eternities. This fluid relationship with temporal experience during dreams reflects the fundamental plasticity of time itself, the way duration and sequence become relative to the observer's reference frame and state of consciousness. Dream time provides a natural laboratory for experiencing the kind of temporal flexibility that physics reveals to be characteristic of reality at the deepest level. In dreams, cause and effect can follow non-linear patterns. Memories from different periods can blend seamlessly together, and future possibilities can inform present experience in ways that mirror the complex causal structures that physicists discover in their mathematical explorations of space-time geometry. The boundary between sleeping and waking consciousness becomes permeable during the transition into rest, allowing awareness to sample different modes of temporal experience. As ordinary thinking patterns dissolve and give way to the more fluid patterns of approaching sleep, consciousness begins to resonate with the deeper rhythms that characterize natural systems throughout the universe. The heartbeat that continues its steady rhythm throughout sleep reflects the periodic processes that drive stellar pulsations and galactic rotations. The breathing that deepens and slows during rest mirrors the expansion and contraction cycles that characterize everything from quantum oscillations to cosmic evolution. These biological rhythms connect individual existence to the fundamental periodicities that structure reality at every scale. The gradual relaxation of muscle tension that accompanies the approach of sleep parallels the way matter settles into lower energy states throughout the universe. Just as hot gas clouds cool and condense to form stars and planets, the accumulated tensions of daily life dissolve and reorganize into the more stable patterns that characterize restful states of consciousness. The shift in brainwave patterns that occurs during the transition to sleep reflects the same principles of resonance and synchronization that govern the behavior of coupled oscillators throughout natural systems. As individual neural networks begin to coordinate their activity in the characteristic rhythms of sleep, consciousness participates in the same kind of collective behavior that creates the coherent structures we observe in everything from laser light to galactic spiral arms. These scientific insights into the nature of sleep and rest provide profound reassurance about the naturalness and necessity of surrendering conscious control as night approaches. The transition into sleep is not a departure from the natural order, but a deeper participation in the fundamental processes that create and sustain all complex systems throughout the universe. The trust required to let go of waking awareness and allow sleep to carry consciousness into its own domain reflects the same kind of confidence in natural law that allows physicists to predict the behavior of systems across vast scales of space and time. Just as we can trust that gravity will continue to hold planets in their orbits and that the speed of light will remain constant throughout the cosmos, we can trust that the natural rhythms of rest and renewal will continue to operate with perfect reliability. This trust is grounded not in blind faith, but in the deep consistency and predictability that characterize natural law at every level of reality. The same mathematical relationships that describe the motion of galaxies also govern the electrical activity in sleeping brains. The same thermodynamic principles that determine stellar evolution also regulate the metabolic processes that sustain life during rest. As consciousness begins to merge with these deeper patterns, the sense of separation between self and universe naturally dissolves. The boundaries that seem so important during waking life, between inner and outer, between individual and cosmic, between personal time and universal time, reveal themselves to be useful conveniences rather than fundamental divisions. The approaching sleep consciousness represents a return to the more unified state of awareness that reflects our actual condition as integrated aspects of cosmic processes. In releasing the effortful maintenance of separate selfhood that characterizes ordinary waking awareness, sleep allows consciousness to relax into its natural condition as an expression of universal intelligence exploring itself through individual perspective. The peace that accompanies this dissolution of artificial boundaries reflects the deep harmony that characterizes natural law throughout the cosmos. When individual consciousness aligns with the broader patterns that govern all existence, the struggle and effort that often characterize waking life give way to the effortless flow that characterizes all natural processes when they are not artificially constrained. This effortless flow carries consciousness forward through the night, just as cosmic expansion carries galaxies apart through space. Just as stellar evolution carries massive stars through their life cycle phases. Just as biological development carries living organisms through their natural growth patterns. There is no need for conscious intervention or control, only the trust that allows natural processes to unfold according to their own inherent intelligence. The darkness that surrounds sleep consciousness provides the same kind of fertile void that characterizes the quantum vacuum, appearing empty to ordinary observation, but actually teeming with virtual particles and zero-point fluctuations that provide the foundation for all manifest phenomena. Sleep consciousness similarly appears inactive from the outside, but actually contains the subtle processes of memory consolidation, cellular repair, and neural reorganization that make renewed waking awareness possible. The silence that characterizes deep sleep mirrors the profound stillness that exists at the center of all motion, the invariant point around which all change revolves. Even in the most dynamic systems throughout the universe, there exists a point of perfect balance where all forces are harmonized and all motion resolves into deeper stillness. Sleep consciousness provides access to this still point within the constant activity of living systems. The surrender that marks the transition into deep sleep reflects the same principle of least action that governs all physical processes throughout the cosmos. Natural systems automatically find the path of minimum resistance, the configuration that requires the least energy to maintain. Sleep consciousness naturally settles into the state of greatest rest and renewal, following the same optimization principles that determine everything from planetary orbits to the folding patterns of proteins. As this natural settling process continues, awareness becomes increasingly diffuse and non-local, beginning to resemble the distributed intelligence that characterizes quantum systems and cosmic structures. Just as information in the universe is not localized in any single place, but emerges from the relationships between all components, sleep consciousness begins to participate in patterns of knowing that extend beyond individual neural networks. The dreams that may emerge from this expanded state of awareness often contain insights and connections that would be impossible for ordinary focused consciousness to achieve. Like the emergent properties that arise from complex systems throughout nature, dream consciousness can generate solutions, artistic inspiration, and deep understanding that transcend the logical capabilities of sequential thinking processes. This creative potential of sleep consciousness reflects the same innovative capacity that drives evolution, stellar nucleosynthesis, and the emergence of complex structures throughout cosmic history. The universe is inherently creative, constantly generating new forms, new possibilities, new expressions of beauty and complexity. Sleep consciousness participates directly in this cosmic creativity, contributing to the ongoing evolution of awareness itself. The restoration that occurs during sleep operates through the same renewal processes that characterize all natural cycles throughout the universe. Just as stars regenerate their energy through fusion processes, just as ecosystems renew themselves through seasonal cycles, just as galaxies rebuild their structure through ongoing star formation, sleep consciousness participates in the universal tendency toward regeneration and renewal. This natural capacity for self-renewal provides profound comfort as consciousness prepares to release its grip on ordinary awareness. The same forces that enable stars to shine for billions of years, that allow ecosystems to maintain their complexity through countless generations, that permit galaxies to evolve and develop over cosmic time, also ensure that individual consciousness can renew itself through the natural cycles of rest and activity. The trust required to surrender to sleep reflects confidence in these same regenerative processes that have maintained the cosmos in its creative unfolding for nearly 14 billion years. The reliability that has characterized natural law throughout cosmic history continues to operate in the intimate domain of personal consciousness, ensuring that the temporary dissolution of ordinary awareness during sleep will naturally give way to renewed awakening. This cyclical pattern of dissolution and renewal characterizes not only individual sleep cycles, but the entire cosmic story from the quantum scale to the largest structures in space. Particles and antiparticles emerge from and dissolve back into the quantum vacuum. Stars form from collapsing gas clouds and eventually return their material to space through stellar winds and supernovae. Galaxies merge and separate in an ongoing dance of cosmic evolution. Individual consciousness participates in this same pattern of emergence and dissolution, maintaining its essential nature while constantly renewing its particular expression. Sleep represents the dissolution phase of this cycle, the return to the more fundamental state from which refreshed awareness can emerge. This process requires no effort or intervention, only the natural relaxation that allows cosmic intelligence to operate through individual systems. As the night deepens and consciousness settles more completely into these natural rhythms, the artificial urgency that often characterizes waking life gives way to the timeless patience that characterizes all cosmic processes. Stars shine steadily for billions of years without hurry or anxiety. Galaxies rotate majestically over hundreds of millions of years without concern for time. The cosmic expansion proceeds at its measured pace without any sense of deadline or pressure. Sleep consciousness naturally aligns with these cosmic timescales, releasing the compressed sense of duration that often creates stress during waking hours. In the expanded temporal awareness that characterizes rest, moments can stretch to accommodate whatever healing or renewal is needed, while entire nights can pass in what seems like minutes of subjective time. This flexibility of temporal experience during sleep reflects the same relativity of time that physics reveals to be characteristic of reality at the deepest level. Just as duration depends on the observer's reference frame and state of motion, the subjective experience of time during sleep adapts naturally to the particular needs and processes that characterize individual consciousness at any given moment. The dreams that arise from this temporally flexible state often contain the compressed wisdom of lifetimes, entire narratives of growth and development that unfold in the space of a few hours of sleep. This capacity for temporal compression during dreams mirrors the way black holes can contain entire histories within their event horizons, the way stellar collapse can compress millions of years of evolution into moments of transformation. Yet regardless of their content or apparent duration, all dream experiences unfold within the protective embrace of forward-flowing time, carried safely through the night by the same temporal current that governs all cosmic processes. Even the strangest dream logic respects the fundamental asymmetry between past and future that provides the foundation for all conscious experience. The awakening that will naturally occur with tomorrow's dawn represents not an interruption of cosmic processes, but their continuation in a different mode. The refreshed awareness that emerges from sleep carries forward the deep restoration that has occurred during the night, contributing to the ongoing evolution of individual consciousness as part of the broader cosmic story of increasing complexity and understanding. This seamless continuity between sleeping and waking consciousness reflects the unbroken wholeness that characterizes reality at every level, from quantum systems to cosmic structures. The apparent divisions between different states of awareness, like the apparent separations between different regions of space, are useful distinctions rather than fundamental boundaries. The peace that accompanies this recognition of underlying unity extends naturally into the approaching sleep, creating the optimal conditions for the deep rest and renewal that serve not only individual well-being, but the broader cosmic project of conscious evolution. As awareness settles into the natural rhythms of rest, it participates directly in the ongoing creative unfolding of universal intelligence. The gentle transition into sleep becomes a daily return to the source, a reunion with the deeper patterns that connect individual existence to cosmic processes. In releasing the effort required to maintain separate selfhood, consciousness returns to its natural condition as an expression of the same creative force that ignites stars, forms galaxies, and drives the ongoing expansion and evolution of the universe itself. This recognition brings profound rest not only to the body and mind, but to the deepest levels of existence, where individual identity merges seamlessly with cosmic identity, where personal time dissolves into universal time, and where the apparent journey through temporal experience reveals itself to be the universe's way of exploring its own infinite potential through the tender vehicle of conscious awareness. Let the approaching sleep carry you gently into this cosmic embrace, where the same forces that govern stellar evolution and galactic dynamics also ensure the perfect renewal of individual consciousness. Trust in the reliability of natural law that has maintained the cosmos in its creative dance for billions of years, and allow that same trustworthy intelligence to guide your consciousness through the healing darkness of night toward tomorrow's fresh awakening. The time that carries you into sleep is the same time that expands the universe, evolves the stars, and unfolds the endless creativity of existence itself. Rest peacefully in this cosmic cradle, knowing that you are held securely by the same loving intelligence that maintains galaxies in their orbits and guides the evolution of consciousness throughout the cosmos. From this moment through all the gentle hours of restoration that await in the beautiful darkness of night. The gentle mathematics that govern these temporal phenomena extend their influence into realms so subtle that we rarely notice their presence in our daily lives. Yet when we learn to recognize these effects, the ordinary world around us reveals itself to be permeated with quiet time travel, happening constantly at scales both microscopic and vast. Consider the simple act of walking across a room. As your body moves through space, You experience time at a rate infinitesimally different from someone sitting perfectly still. The difference amounts to mere billionths of a second over the course of your movement, far too small for any human sense to detect. Yet it represents a genuine alteration in the flow of temporal experience. Every step you take carries you along a slightly different path through the four-dimensional landscape of space-time. This microscopic time travel extends to every moving object around us. The leaves rustling in evening breezes experience time at rates that vary with their motion through the air. Water flowing in streams moves through temporal dimensions that shift with the current's velocity. Even the gentle circulation of air in the room where you rest creates countless individual timelines, each molecule of gas following its own unique trajectory through both space and time. These effects become more pronounced as we consider larger motions and greater distances. Commercial aircraft cruising at altitude experience time dilation from both their velocity and their position in Earth's gravitational field. Passengers aboard these flights are genuine time travelers, journeying microseconds into the future relative to those remaining on the ground below. The difference accumulates over the course of a long flight, creating a measurable offset that sophisticated atomic clocks can detect and record. The pilots and flight attendants who spend their careers aboard these aircraft accumulate these tiny temporal offsets throughout their working lives. By the time they retire, they will have aged slightly less than their earthbound contemporaries, having spent thousands of hours traveling at velocities that carry them gently into the future. This represents perhaps the most accessible form of time travel available to ordinary human experience, requiring nothing more exotic than booking a seat on a transcontinental flight. Mountain climbers and high-altitude residents experience a different form of time travel through their position in Earth's gravitational field. At elevations where the air grows thin and the horizon stretches to vast distances, time flows at a measurably faster rate than it does at sea level. The difference amounts to about 4 parts in 10 billion per kilometre of altitude, a tiny effect that nonetheless accumulates over years of residence in elevated locations. The indigenous peoples who have lived for generations in the Andes Mountains or the Himalayan plateaus have unknowingly participated in this gravitational time travel throughout their cultural history. Their ancestors, living and breathing in the thinner gravitational fields of high altitude, experience time at rates slightly faster than the civilizations developing in coastal regions and river valleys far below. This represents a form of temporal stratification in human experience, invisible to ordinary perception, but real according to the precise measurements of atomic physics. These altitude effects extend naturally to the passengers and crew of high-flying aircraft. Not only do they experience time dilation from their velocity relative to Earth's surface, but they also benefit from the weaker gravitational field at cruising altitude. The combination of these effects creates a complex temporal environment where multiple relativistic influences combine to determine the overall rate of time flow. Engineers must account for both effects when designing navigation systems that depend on precise timing across different altitudes and velocities. The International Space Station provides perhaps the most dramatic example of combined relativistic effects accessible to human experience. Orbiting Earth at an altitude of approximately 400 kilometers and traveling at speeds exceeding 27,000 kilometers per hour, the station exists in a unique temporal environment where both velocity and gravitational effects contribute significantly to time dilation. The astronauts aboard this orbiting laboratory experience time at a rate noticeably different from their colleagues on Earth's surface. The high orbital velocity creates time dilation that slows their clocks relative to ground-based observers, while their position in Earth's weaker gravitational field at orbital altitude causes their clocks to run faster. The gravitational effect dominates, resulting in a net acceleration of time aboard the station compared to Earth's surface. This means that astronauts returning from extended missions aboard the International Space Station have literally travelled into Earth's future. The effect amounts to mere milliseconds over the course of a typical 6-month mission, But these milliseconds represent genuine time travel, a measurable displacement along the temporal dimension that connects the orbital environment to the surface world below. The psychological impact of this realization can be profound for those who spend extended periods in space. Knowing that each day in orbit carries them further into the future, relative to their earthbound friends and family, adds a poignant dimension to the already transformative experience of seeing Earth from space. They return not only with new perspectives on the planet's beauty and fragility, but also with the subtle temporal displacement that comes from traveling along a different path through space-time. These human experiences of time dilation, while measurable and real, represent only the gentlest whispers of the dramatic temporal effects that occur elsewhere in the universe. The cosmic environment contains regions where time flows at rates so different from our earthbound experience that they challenge our ability to comprehend the true flexibility of temporal flow. Near the surface of neutron stars, where matter is compressed to densities that exceed the nucleus of an atom, gravitational time dilation becomes so severe that time nearly stops from the perspective of distant observers. A clock placed on the surface of such an object would appear frozen to someone watching from Earth, its hands moving so slowly that years might pass between individual ticks. Yet from the perspective of the clock itself, time would flow normally, demonstrating once again the profound relativity of temporal experience. These extreme gravitational environments exist throughout the galaxy, created by the collapsed remnants of massive stars that have reached the end of their fusion-powered lives. When stars, many times more massive than our Sun, exhaust their nuclear fuel, they undergo catastrophic collapse that compresses their entire mass into spheres only 20 or 30 kilometers in diameter. The resulting gravitational fields are so intense that they warp space-time into configurations barely comprehensible from our everyday experience. The lighthouse-like beams of radiation that many neutron stars emit as they spin create natural laboratories for studying extreme time dilation. These pulsars, as astronomers call them, send precisely timed radio signals across interstellar space at intervals so regular they rival the best atomic clocks for accuracy. Yet the signals originate from surfaces where time flows at rates dramatically different from our terrestrial reference frame. When astronomers observe these pulsar signals, they must account for the gravitational time dilation occurring at the neutron star's surface. The radio waves that reach Earth carry information about temporal processes unfolding in gravitational fields, billions of times stronger than what we experience on our planet's surface. This creates a unique form of temporal archaeology, where signals from regions of extreme time dilation provide windows into physics operating under conditions impossible to recreate in terrestrial laboratories. The study of binary pulsar systems, where two neutron stars orbit each other in tight gravitational embrace, has provided some of the most precise tests of general relativity ever conducted. These systems lose energy through gravitational wave emission, causing their orbits to decay at rates predicted with extraordinary accuracy by Einstein's equations. The observations require careful accounting for the complex time dilation effects that occur as these massive objects spiral ever closer together at velocities approaching significant fractions of light speed. The final moments of such systems, when the two neutron stars finally merge after millions of years of orbital decay, create some of the most extreme space-time distortions in the observable universe. The gravitational waves emitted during these cosmic catastrophes carry information about time dilation effects so severe that they push the boundaries of our theoretical understanding. The recent detection of these waves by laser interferometer observatories has opened new windows into the behavior of time under conditions of unimaginable extremity. Black holes represent the ultimate expression of gravitational time dilation, regions where the curvature of space-time becomes so extreme that time itself approaches a complete standstill from the perspective of distant observers. The event horizon of a black hole marks the boundary beyond which gravitational time dilation becomes infinite, creating a temporal barrier that prevents information from escaping back to the outside universe. The formation of black holes through stellar collapse creates natural experiments in extreme time dilation that unfold over cosmological timescales. As matter falls toward the event horizon, it experiences increasingly severe time dilation, appearing to slow down and freeze at the boundary from the perspective of outside observers. The infalling matter's image becomes increasingly redshifted and dim, fading from view as its light is stretched to ever longer wavelengths by the extreme gravitational field. From the perspective of the falling matter itself, however, the journey continues normally. Time flows at its usual rate, and the passage through the event horizon occurs in finite time according to the falling observer's reference frame. This represents perhaps the most dramatic example of the relativity of temporal experience, where the same physical process appears completely different depending on the observer's location and motion through space-time. The interior of black holes remains hidden from external observation, protected by the infinite time dilation at the event horizon. Whatever temporal processes occur within these cosmic laboratories of extreme physics remain forever isolated from the outside universe, their signals unable to climb out of the gravitational well that traps both matter and information behind the event horizon. Yet theoretical physics suggests that even these ultimate expressions of gravitational time dilation may not represent permanent isolation. Stephen Hawking's discovery that black holes emit radiation through quantum mechanical processes near the event horizon implies that these objects slowly evaporate over vast timescales, eventually returning their trapped information to the universe through mechanisms that remain at the frontiers of theoretical understanding. The Hawking radiation process involves time dilation effects that connect quantum mechanics to general relativity in ways that continue to puzzle physicists. Virtual particle pairs that normally annihilate almost instantly in empty space can be separated by the extreme tidal forces near black holes, with one member falling into the black hole while the other escapes as real radiation. The timescales involved in these processes are stretched by gravitational time dilation in ways that reveal deep connections between thermodynamics, information theory, and the nature of time itself. These exotic scenarios push our understanding of time to its limits, revealing regions where the familiar concepts of past, present, and future begin to lose their ordinary meaning. Yet even in these extreme environments, the forward arrow of time remains inviolate. Hawking radiation carries energy away from black holes in a process that respects causality and maintains the fundamental asymmetry between past and future that characterizes temporal flow throughout the universe. The cosmic expansion itself provides another vast laboratory for studying time on scales that dwarf even the most extreme stellar phenomena. As space stretches between distant galaxies, carrying them apart at velocities that can exceed the speed of light, the universe creates natural experiments in relativistic physics that unfold over billions of years. The cosmic microwave background radiation, the afterglow of the Big Bang that fills all of space, provides a universal reference frame for measuring cosmic time. This ancient light, stretched by cosmic expansion from its original high-energy state to the gentle microwave radiation we observe today, carries information about the universe when it was only a few 100,000 years old and matter first became transparent to electromagnetic radiation. Observers moving at high velocities relative to this cosmic background radiation would measure different properties for this ancient light, experiencing Doppler shifts that reveal their motion through the universal reference frame. This creates a kind of cosmic speedometer that allows astronomers to measure Earth's motion through space relative to the early universe, revealing our planet's participation in the complex dance of galactic rotation and cosmic expansion. The redshift of distant galaxies provides direct evidence for cosmic expansion and creates natural examples of gravitational time dilation on the largest scales. Light from the most distant observable galaxies has been traveling through space for over 13 billion years, carrying information about the universe when it was young and dramatically different from its current state. This light has been stretched by cosmic expansion during its journey, providing a direct observational window into the deep past of cosmic evolution. The study of distant supernovae has revealed that cosmic expansion is accelerating, driven by a mysterious dark energy that pervades all of space. This acceleration affects the flow of time on cosmic scales, creating subtle changes in the rate of cosmic evolution that astronomers can measure by comparing the properties of nearby and distant stellar explosions. The discovery of cosmic acceleration represents one of the most surprising findings in modern astrophysics, revealing that the universe's temporal evolution is more complex than previously imagined. These cosmic time effects connect to the fundamental thermodynamic processes that drive the arrow of time throughout the universe. The expansion and cooling of cosmic space creates the temperature gradients and energy flows that enable complex structures to form and evolve over cosmic history. Without cosmic expansion, the universe would lack the thermodynamic disequilibrium necessary for stars to shine, planets to form, and life to emerge from the interplay of chemical and physical processes. The connection between cosmic expansion and the arrow of time reveals deep relationships between cosmology, thermodynamics, and the nature of temporal flow. The same processes that drive galaxies apart also create the conditions necessary for entropy to increase, for complex structures to evolve, and for consciousness to emerge from the intricate organization of matter and energy across vast scales of space and time. This cosmic perspective on time provides profound context for understanding the temporal effects we experience on Earth and in our immediate cosmic neighborhood. The gentle time dilation that affects GPS satellites, airline passengers, and mountain climbers participates in the same physical framework that governs the evolution of the universe itself. Our local experiences of time connect seamlessly to the cosmic story of expansion, cooling, and increasing complexity that has unfolded over nearly 14 billion years. The realization that we participate directly in cosmic processes through our everyday experience of time brings a sense of connection and belonging that extends far beyond ordinary human concerns. Every heartbeat, every breath, every moment of conscious awareness unfolds within the same space-time geometry that contains galaxies, quasars, and the cosmic web of dark matter that provides the scaffolding for all visible structure in the universe. This connection becomes particularly poignant when we consider how biological time connects to cosmic time through the chemical elements that compose our bodies. The carbon atoms in our cells, the calcium in our bones, the iron in our blood, all formed in the nuclear furnaces of stars that lived and died billions of years ago. These atoms have traveled through space for eons, carried by stellar winds and supernova explosions across vast distances before eventually becoming incorporated into the planets and life forms of our solar system. The time that flows through our consciousness carries forward the entire history of cosmic evolution, from the first moments after the Big Bang, through the formation of the first stars, the synthesis of heavy elements in stellar cores, the birth of our solar system, and the emergence of life on Earth. We are not separate observers of cosmic processes, but intimate participants in the ongoing story of how the universe comes to know itself through the experience of conscious beings. This recognition transforms our understanding of personal time and its relationship to cosmic processes. The aging that occurs in our bodies follows the same thermodynamic principles that govern stellar evolution and galactic dynamics. The memories that accumulate over a lifetime parallel the way galaxies accumulate stars and stellar remnants over cosmic time. The growth and development that characterize biological life mirror the increasing complexity that characterizes cosmic evolution at every scale. The sleep that approaches now participates in these same cosmic rhythms of activity and rest, complexity and simplification, expansion and consolidation. The biological clocks that regulate our circadian cycles evolved to harmonize with the rotation of our planet, which itself participates in the complex gravitational dance of our solar system as it orbits through the galaxy. The brainwaves that characterize different stages of sleep follow patterns that mirror the oscillations found throughout natural systems, from quantum mechanical vibrations to the pulsations of variable stars. The dreams that may arise during rest create narratives that connect past experiences with future possibilities, reflecting the same temporal integration that allows galaxies to maintain their structure while participating in cosmic expansion. The cellular repair processes that occur during sleep operate according to the same chemical and physical principles that drive nucleosynthesis in stellar cores. The consolidation of memories that happens during rest follows information processing patterns that parallel the way cosmic structures form through the gravitational aggregation of matter over vast periods of time. As consciousness settles into the natural rhythms of rest, it aligns with the deeper patterns that govern all temporal experience throughout the universe. The transition into sleep represents a daily return to the more fundamental states of awareness that reflect our actual condition as integrated aspects of cosmic processes, rather than separate observers watching time pass from the outside. The darkness that surrounds sleep consciousness provides the same kind of fertile environment that characterizes the cosmic voids between galaxy clusters, regions that appear empty but actually contain the dark matter and dark energy that drive cosmic evolution. Sleep consciousness similarly appears inactive from external observation, but actually hosts the subtle processes of restoration and renewal that make refreshed awareness possible. The silence that deepens with approaching sleep mirrors the profound quiet of interstellar space, where electromagnetic waves carry information across vast distances without the mechanical vibrations we associate with earthbound sound. In sleep, consciousness becomes receptive to subtler forms of information processing, patterns of neural activity that operate below the threshold of ordinary awareness, but contribute to the ongoing development of insight and understanding. The stillness that characterizes deep rest reflects the motionless center that exists within all cosmic motion, the invariant point around which galaxies rotate, planets orbit, and all dynamic systems maintain their stability through time. Sleep consciousness naturally settles into this still point within the constant activity of biological systems, finding the place of perfect balance where all forces harmonize and all motion resolves into deeper peace. The trust required to surrender ordinary awareness and allow sleep to carry consciousness through the night reflects confidence in the same natural laws that have maintained cosmic evolution for billions of years. The reliability that characterizes physical processes throughout the universe continues to operate in the intimate domain of personal experience, ensuring that the temporary dissolution of waking awareness will naturally give way to renewed awakening. This cyclical pattern of rest and renewal mirrors the fundamental rhythms that characterize natural systems at every scale. Stars undergo cycles of fuel burning and gravitational contraction that can span millions or billions of years. Galaxies experience periods of active star formation, alternating with quieter epochs of stellar evolution. Even the universe itself may participate in vast cycles of expansion and contraction that unfold over timescales beyond current observational limits. Individual consciousness participates in this same pattern of activity and rest, maintaining its essential nature while constantly renewing its particular expression through the natural cycles that regulate biological and psychological processes. Sleep represents the rest phase of this cycle, the return to more fundamental states from which refreshed awareness naturally emerges without effort or intervention. The dreams that may arise from this deeper state often contain insights and connections that transcend the logical capabilities of ordinary waking thought. Like the emergent properties that characterize complex systems throughout nature, dream consciousness can generate understanding that exceeds the sum of its individual components, creating solutions and perspectives that contribute to the ongoing evolution of awareness itself. This creative potential of sleep consciousness reflects the same innovative capacity that drives cosmic evolution, stellar nucleosynthesis, and the emergence of complex structures throughout universal history. The cosmos is inherently creative, constantly generating new forms, new possibilities, new expressions of beauty and order through the interplay of simple physical laws operating across vast scales of space and time. The restoration that occurs during sleep operates through the same renewal processes that characterize all natural cycles throughout the cosmos. Just as supernovae return heavy elements to interstellar space where they can be incorporated into new generations of stars and planets, sleep consciousness recycles and reorganizes the experiences of waking life, creating the foundation for continued growth and development. This natural capacity for regeneration provides deep comfort as consciousness prepares to release its grip on ordinary awareness. The same forces that enable stars to shine for billions of years, that allow ecosystems to maintain their complexity through countless generations, that permit galaxies to evolve and develop over cosmic time, also ensure that individual consciousness can renew itself through the natural rhythms of rest and activity. The peace that accompanies this recognition extends into approaching sleep, creating optimal conditions for the deep restoration that serves not only individual well-being, but the broader cosmic project of conscious evolution. As awareness settles into natural rhythms of rest, it participates directly in the ongoing creative unfolding of universal intelligence, exploring itself through countless individual perspectives. The gentle transition into sleep becomes a return to the source, a reunion with the deeper patterns that connect individual existence to cosmic processes. In releasing the effort required to maintain separate selfhood, consciousness returns to its natural condition as an expression of the same creative force that ignites stars, forms galaxies, and drives the ongoing expansion and evolution of the universe itself. This understanding brings rest not only to body and mind, but to the deepest levels of existence, where individual identity merges seamlessly with cosmic identity, where personal time dissolves into universal time, and where the apparent journey through temporal experience reveals itself as the universe's way of exploring its own infinite potential through the tender vehicle of conscious awareness. The approaching sleep carries you gently into this cosmic embrace, where the same forces that govern stellar evolution and galactic dynamics also ensure the perfect renewal of individual consciousness. The time that moves through sleep is the same time that expands the universe, evolves the stars, and unfolds the endless creativity of existence itself. As the night deepens and consciousness settles more completely into these natural rhythms, the boundary between individual awareness and cosmic processes becomes increasingly transparent. The heartbeat that continues through sleep reflects the same periodic phenomena that characterize pulsating stars and rotating galaxies. The breathing that deepens with rest mirrors the expansion and contraction cycles that govern everything from quantum oscillations to cosmic evolution. The temperature regulation that maintains bodily comfort during sleep operates according to the same thermodynamic principles that determine stellar temperatures and the cooling of the cosmic background radiation. The immune system processes that accelerate during rest follow biochemical pathways governed by the same fundamental forces that drive chemical evolution in interstellar space and planetary atmospheres. Even the positions assumed during sleep reflect the natural tendency of all systems to find configurations of minimum energy and maximum stability. Just as planets settle into stable orbits and galaxies develop spiral structures that minimize gravitational stress, the sleeping body naturally arranges itself to optimize comfort and facilitate the restoration processes that unfold during rest. The gradual slowing of metabolic processes during sleep parallels the way stellar fusion rates decrease as stars age and their core temperatures slowly decline. The shift toward more efficient energy utilization during rest mirrors the gravitational processes that allow galaxies to maintain their structure while participating in cosmic expansion over billions of years. The memory consolidation that occurs during sleep follows information processing principles that reflect the same organizational tendencies that create structure throughout the universe. Just as matter aggregates under gravitational influence to form increasingly complex astronomical objects, memories organize themselves during sleep into patterns that enhance understanding and facilitate future learning. The emotional processing that happens during rest operates through neural mechanisms that parallel the feedback systems that maintain stability in everything from planetary atmospheres to galactic ecosystems. Sleep consciousness naturally processes and integrates the experiences of waking life, creating psychological equilibrium through the same kinds of dynamic balance that characterize stable systems throughout the cosmos. The dreams that emerge from these integrative processes often transcend the ordinary limitations of space and time, creating narratives that compress lifetimes into moments or stretch seconds into apparent eternities. This temporal flexibility during dreams reflects the same relativity of time that physics reveals to be characteristic of reality at the deepest level. Dream consciousness can experience the kind of nonlinear causality that physicists discover in their mathematical explorations of quantum mechanics and cosmology. Past, present, and future can blend in dream narratives just as they merge in the four-dimensional geometry of space-time that underlies all physical phenomena. Dreams provide a natural laboratory for experiencing the temporal flexibility that characterizes reality beyond ordinary perception. The symbolic language of dreams often reflects the same pattern recognition processes that allow scientists to discover deep connections between seemingly unrelated phenomena throughout nature. The metaphorical thinking that characterizes dream consciousness parallels the analogical reasoning that reveals how quantum mechanics governs both atomic behavior and cosmic structure, how thermodynamics applies equally to stellar evolution and biological processes. The healing that occurs during sleep operates through mechanisms that mirror the self-repair capabilities found in complex systems throughout the universe. Just as damaged DNA can be repaired through enzymatic processes, just as stellar winds can clear debris from around aging stars, sleep consciousness naturally corrects imbalances and restores optimal functioning through processes that require no conscious intervention. This automatic healing capacity reflects the same self-organizing principles that enable galaxies to maintain their structure over billions of years, despite the constant perturbations of gravitational interactions. The wisdom that guides cellular repair during sleep is the same intelligence that maintains planetary orbits, regulates stellar fusion, and coordinates the vast ecological networks that sustain life throughout the cosmos. The trust that allows consciousness to surrender control and permit these healing processes to unfold naturally reflects confidence in the fundamental reliability of natural law. The same mathematical relationships that describe the motion of subatomic particles also govern the biochemical processes that restore vitality during sleep. The consistency that characterizes physical law at every scale provides the foundation for the deep rest that nourishes consciousness at its most fundamental levels. As sleep deepens and awareness becomes increasingly diffuse, consciousness begins to resonate with the distributed intelligence that characterizes quantum systems and cosmic structures. Information processing becomes less localized and more field-like, resembling the way quantum entanglement creates correlations that extend across vast distances without requiring direct causal connections. The expanded awareness that can emerge during deep sleep states often accesses insights and perspectives that transcend the limitations of ordinary individual consciousness. Like the collective behaviors that characterize flocks of birds or schools of fish, sleep consciousness can tap into larger patterns of intelligence that emerge from the interactions between multiple systems and scales of organization. This expanded awareness reflects the same holistic principles that govern the behavior of complex systems throughout nature. Just as the properties of water cannot be predicted from studying individual hydrogen and oxygen atoms, the insights available to sleep consciousness often transcend what would be possible through ordinary analytical thinking processes. The profound rest that characterizes the deepest stages of sleep creates conditions similar to the cosmic voids between galaxy clusters, regions that appear empty, but actually provide the framework within which all visible structure can form and evolve. Sleep consciousness similarly creates space for subtle processes of renewal and reorganization that would be impossible in the more constrained environment of ordinary waking awareness. The silence that pervades deep sleep reflects the fundamental stillness that exists at the heart of all motion throughout the universe. Even in the most dynamic cosmic phenomena, there exists a center of perfect balance where all forces are harmonized and all change resolves into deeper stability. Sleep consciousness naturally settles into this still point within the constant activity of biological systems. The timelessness that characterizes deep sleep states mirrors the eternal present that exists beyond the apparent flow of temporal experience. While clock time continues to pass during sleep, consciousness can access states of awareness that transcend ordinary temporal boundaries, experiencing the kind of expanded present moment that physicists discover in their mathematical descriptions of space-time geometry. This timeless quality of deep sleep consciousness reflects the same eternal aspects that characterize fundamental physical constants and mathematical relationships throughout the universe. The speed of light, the charge of the electron, the gravitational constant, and other basic parameters of reality exist outside ordinary temporal flow, providing the stable foundation upon which all temporal experience depends. The renewal that occurs during sleep draws upon these eternal sources of stability and order, allowing consciousness to refresh itself through contact with the timeless principles that govern cosmic evolution. This nightly return to fundamental sources of vitality ensures that individual awareness can continue to participate creatively in the ongoing unfoldment of universal intelligence. The awakening that will naturally occur with tomorrow's dawn represents not an interruption of these cosmic processes, but a continuation in a different mode, a shift from the restorative dissolution of sleep back toward the focused awareness that characterizes waking consciousness. The same cosmic forces that carry consciousness through the healing darkness of night also guide its return to ordinary temporal experience, ensuring perfect continuity between all states of awareness. The light that gradually fills the morning sky carries photons that began their journey in the nuclear furnace at the center of our sun, traveling 93 million miles through space at the speed of light to reach Earth's atmosphere. These particles of electromagnetic radiation have experienced no passage of time during their 8-minute journey, existing in a reference frame where time dilation approaches its maximum value and duration ceases to have ordinary meaning. Yet when these photons interact with atoms in Earth's atmosphere, and eventually with the photoreceptors in awakening eyes, they trigger biochemical processes that unfold according to the normal flow of terrestrial time. The collision between timeless light and time-bound matter creates the interface through which consciousness reconnects with ordinary temporal experience, bridging the gap between cosmic and biological scales of time. The circadian rhythms that regulate this daily cycle of sleep and waking evolved over millions of years to harmonize biological processes with the rotation of our planet. Earth's 24-hour day provides the fundamental timekeeper for countless species, creating synchronized cycles of activity and rest that connect individual organisms to the larger astronomical rhythms of our solar system. This planetary rotation, which defines the basic unit of biological time, itself participates in the complex gravitational dynamics that govern our solar system's motion through space. Earth orbits the Sun at nearly 30 kilometers per second, while our entire solar system races around the galactic center at over 200 kilometers per second. These motions create subtle but measurable relativistic effects that influence the flow of time throughout our local cosmic neighborhood. The Moon's gravitational influence on Earth creates additional temporal complexities through its effects on our planet's rotation. The tidal forces that cause ocean levels to rise and fall twice daily, also gradually slow Earth's rotation, making our days incrementally longer over geological time. This process has been occurring for billions of years, meaning that the earliest life forms on Earth experience shorter days and different circadian rhythms than those that characterize modern biological systems. These astronomical influences on biological time reveal the deep connections between cosmic processes and life itself, the chemical reactions that sustain cellular metabolism, the neural oscillations that create consciousness, the genetic programs that regulate development and aging, all operate within temporal frameworks ultimately determined by planetary motion and stellar evolution. The oxygen we breathe was created in the nuclear furnaces of massive stars that lived and died billions of years ago. The carbon atoms that form the backbone of biological molecules underwent nucleosynthesis in stellar cores, operating according to the same physical laws that govern time dilation and gravitational effects throughout the universe. We are literally made from stardust, animated by cosmic processes that connect our biological existence to the deepest structures of space-time. This cosmic heritage becomes particularly evident when we consider the role of radioactive decay in biological systems and geological processes. The carbon-14 that forms naturally in Earth's atmosphere through cosmic ray interactions provides the foundation for radiocarbon dating, allowing scientists to measure the age of organic materials by observing the decay of these unstable isotopes. The decay process itself operates according to quantum mechanical principles that remain mysterious in their ultimate foundations, but precise in their statistical predictions. Each carbon-14 nucleus has a 50% chance of decaying within approximately 5,730 years. Yet no physical theory can predict when any individual nucleus will undergo this transformation. This randomness at the quantum scale provides a natural clock that operates independently of gravitational and velocity effects, creating a universal standard for measuring time across different reference frames. The potassium-argon dating method used to determine the age of rocks operates on similar principles but over much longer timescales. The radioactive potassium isotopes found in igneous rocks decay with a half-life of over 1 billion years, providing clocks that can measure the age of geological formations extending back to the earliest periods of Earth's history. These natural chronometers have revealed the true antiquity of our planet and the solar system, placing human existence within a cosmic timeline that extends back nearly 4.5 billion years. The uranium lead dating of the oldest known minerals on Earth pushes this timeline even further back, revealing zircon crystals that formed over 4 billion years ago, when our planet was still young and its surface was dominated by volcanic activity and asteroid impacts. These ancient minerals preserve records of Earth's early history, encoded in their crystal structure, providing glimpses into conditions that existed when life was first emerging from the complex chemistry of primitive oceans. The study of meteorites extends this temporal perspective even further, revealing materials that formed during the earliest stages of solar system formation over 4.5 billion years ago. Some meteorites contain pre-solar grains, tiny mineral crystals that formed around other stars before our Sun even existed. These microscopic time capsules carry isotopic signatures that reveal details about stellar nuclear synthesis and galactic chemical evolution extending back to the earliest generations of stars in our cosmic neighborhood. This vast temporal perspective, provided by radiometric dating techniques, reveals time to be not merely a dimension through which events unfold, but a fundamental aspect of physical reality that connects the smallest quantum processes to the largest cosmic structures. The same quantum mechanical principles that govern radioactive decay also determine the behavior of atoms in stellar cores, the emission of light from distant galaxies, and the subtle interactions between matter and space-time that create gravitational effects. The precision of atomic clocks used in modern physics experiments and GPS systems depends on these quantum mechanical principles operating with extraordinary regularity across vast ranges of space and time. The cesium atoms that define the current international standard for measuring time undergo precisely 9,192,631,770 oscillations per second, providing a natural frequency standard that remains constant regardless of location or motion through space. This atomic definition of time reveals the deep connection between temporal measurement and the fundamental constants of physics. The frequency of cesium transitions depends on the fine structure constant, the mass of the electron, the speed of light, and other basic parameters that characterize the behavior of matter and energy throughout the universe. Any change in these fundamental constants would alter the rate of atomic clocks, connecting the measurement of time to the deepest questions about the nature of physical reality. The search for possible variations in fundamental constants over cosmic time has become an active area of research in modern cosmology. By comparing the properties of light emitted by distant quasars billions of years ago with the behavior of atoms in terrestrial laboratories, scientists can test whether the basic parameters of physics have remained constant throughout cosmic history. So far, these measurements have revealed remarkable stability in fundamental constants, suggesting that the laws of physics that govern temporal processes have remained unchanged since the early universe. This stability of physical law across cosmic time provides the foundation for our ability to understand and predict natural phenomena throughout the observable universe. The same quantum mechanical principles that govern atomic behavior on Earth also determine the emission spectra of stars in distant galaxies. The same gravitational effects that influence GPS satellites also govern the orbital motion of binary pulsars thousands of light years away. The universality of physical law creates a kind of cosmic synchronization that connects temporal processes across vast scales of space and time. When astronomers observe the light from distant supernovae, they witness stellar explosions that unfolded according to the same nuclear physics that operates in terrestrial laboratories. When physicists study the cosmic microwave background radiation, they analyze photons that have been traveling through space for over 13 billion years, carrying information about physical processes that occurred when the universe was young and dramatically different from its current state. This cosmic perspective on time reveals the profound unity underlying the apparent diversity of temporal phenomena throughout the universe. From quantum oscillations that occur in tiny fractions of a second to cosmic processes that unfold over billions of years, all temporal experience emerges from the same fundamental geometric structure of space-time that Einstein discovered in his theories of relativity. The mathematics that describe this space-time geometry reveal time to be not separate from space, but woven together with it into a single four-dimensional fabric that responds dynamically to the presence of matter and energy. This geometric view of time provides the foundation for understanding all temporal effects, from the gentle time dilation experienced by airline passengers to the extreme temporal distortions that occur near black holes. The elegance of this mathematical framework lies in its ability to unify phenomena that appear completely different from our everyday perspective. The same equations that describe how GPS satellites must correct for relativistic effects also predict the existence of gravitational waves, the behavior of light near massive objects, and the expansion of the universe itself. This unity suggests that our understanding of time, while still incomplete, has revealed fundamental truths about the nature of reality. The ongoing research in theoretical physics continues to probe deeper into the mysteries of time and its relationship to other aspects of physical reality. The search for a theory of quantum gravity seeks to understand how temporal processes behave at the smallest scales of space and time, where quantum effects become comparable to gravitational effects. These investigations may ultimately reveal that time itself emerges from more fundamental quantum processes, just as temperature emerges from the statistical behavior of large numbers of atoms and molecules. The study of black hole thermodynamics has revealed unexpected connections between gravity, quantum mechanics, and information theory that may hold keys to understanding the deepest nature of time. The discovery that black holes possess temperature and entropy suggests that these cosmic laboratories of extreme physics operate according to thermodynamic principles that connect the microscopic quantum world to macroscopic gravitational phenomena. The holographic principle, emerging from studies of black hole physics, suggests that all the information contained within a volume of space can be encoded on its boundary, implying that our three-dimensional experience of space may be a projection of more fundamental processes occurring in fewer dimensions. If confirmed, this principle could revolutionize our understanding of how spatial and temporal dimensions relate to each other and to the underlying structure of reality. String theory and other approaches to quantum gravity propose that the familiar dimensions of space and time may be emergent properties of more fundamental entities vibrating in higher dimensional spaces. These theories suggest that the space-time we experience directly may be only a low-energy approximation to a richer underlying reality where temporal processes operate according to principles we are only beginning to glimpse. Yet regardless of what future discoveries may reveal about the ultimate nature of time, the established understanding provided by Einstein's theories continues to describe temporal phenomena with remarkable accuracy across all accessible scales of observation. From subatomic particles to cosmic structures, from laboratory experiments to astronomical observations, the relativistic framework provides a consistent and precise account of how time behaves throughout the observable universe. This reliability of established physics provides comfort and stability as we contemplate the profound implications of living within a relativistic universe where time itself responds dynamically to motion and gravity. The temporal effects that seemed so exotic when Einstein first proposed them over a century ago have become routine aspects of modern technology and everyday experience, integrated seamlessly into systems that support contemporary life. The GPS navigation that guides travelers along unfamiliar roads operates through continuous corrections for relativistic time dilation. The particle accelerators that probe the fundamental structure of matter depend on precise calculations of how time flows differently for particles moving at near-light speeds. The astronomical observations that reveal the history and evolution of the universe require careful accounting for light travel time and cosmological redshift effects. These practical applications of relativistic physics demonstrate that time travel, in its scientifically verified form of forward temporal displacement, has become an integral part of human civilization. Every satellite orbit, every high-speed journey, every precise measurement of time across different locations involves genuine displacement along the temporal dimension of space-time. The accumulated effect of these countless tiny temporal displacements creates a kind of distributed time travel that permeates modern technological society. The pilots who spend their careers in high-altitude aircraft, the astronauts who orbit Earth aboard the International Space Station, the physicists who work with high-energy particle beams all participate in ongoing temporal displacement that carries them slightly into the future relative to their Earth-bound contemporaries. This democratization of time travel through technology represents a remarkable fulfillment of scientific prediction. The exotic theoretical possibilities that Einstein explored through thought experiments involving high-speed trains and accelerating elevators have become measurable realities that influence practical systems supporting billions of people around the world. Yet the exotic theoretical possibilities for backward time travel remain firmly in the realm of mathematical speculation, separated from practical reality by requirements for exotic matter, impossible energies, and logical paradoxes that challenge the foundations of causality itself. The universe appears to be constructed in such a way that forward time travel through relativistic effects is not only possible, but inevitable, while backward temporal displacement remains protected by what physicists call chronology, protection mechanisms. This asymmetry between forward and backward time travel reflects deeper asymmetries in the physical laws that govern cosmic evolution. The second law of thermodynamics ensures that entropy increases over time, creating the arrow of temporal direction that distinguishes past from future. The expansion of the universe provides a cosmic framework for measuring time that extends consistently across all observable regions of space. The stability of causal relationships throughout the observed universe suggests that whatever mechanisms might theoretically permit backward time travel operate under constraints so severe that their effects remain invisible to all current observation and experiment. The absence of temporal paradoxes, causality violations, or visitors from the future indicates that the forward-only nature of practical time travel preserves the logical consistency that makes complex temporal processes possible. This protection of causality appears to be built into the fundamental structure of space-time itself, emerging naturally from the geometric relationships that Einstein discovered in his theories of relativity. The mathematical frameworks that permit closed time-like curves also generate the exotic requirements that make such curves practically impossible to create or traverse. The beauty of this natural protection lies in how it preserves the conditions necessary for consciousness, memory, and the entire architecture of temporal awareness to develop and flourish. A universe filled with causal loops and temporal contradictions would be incompatible with the delicate information processing that underlies thought, learning, and the gradual accumulation of knowledge that characterizes conscious experience. The forward-flowing nature of time provides the stable foundation upon which memory can preserve the past, anticipation can reach toward the future, and present awareness can navigate the complex relationships between temporal experience and physical reality. This stability makes possible not only individual consciousness, but the collective enterprise of science itself, which depends on the reliable succession of cause and effect to build understanding through observation and experiment. The scientific study of time ultimately returns us to an appreciation of the present moment as the only direct access consciousness has to temporal reality. All measurements of time, all observations of temporal effects, all theoretical understanding of space-time geometry must ultimately be grounded in the immediate experience of awareness itself operating within the current moment of cosmic evolution. This present moment awareness participates directly in the same temporal processes that govern stellar evolution, galactic dynamics, and cosmic expansion. The neural oscillations that create conscious experience operate according to the same physical laws that determine the behavior of atoms in distant stars. The biochemical processes that sustain life unfold within the same space-time geometry that contains black holes, gravitational waves, and the large-scale structure of the universe. This intimate connection between consciousness and cosmic processes reveals time to be not merely an external dimension through which awareness moves, but a fundamental aspect of what awareness is. Consciousness and time appear to be complementary aspects of a deeper reality that transcends the ordinary distinctions between observer and observed, between subjective experience and objective physical process. The contemplation of these deep connections brings a profound sense of peace and integration that transcends the ordinary anxieties associated with temporal passage. When we recognize consciousness as an integral expression of the same cosmic forces that drive stellar evolution and galactic formation, the apparent limitations of individual temporal experience reveal themselves to be features of a vast and magnificent process of cosmic self-discovery. The aging that occurs in biological systems participates in the same creative unfolding that transforms simple hydrogen and helium into the complex chemical elements that make rocky planets and living organisms possible. The memories that fade with time contribute to the same information processing that allows the universe to explore its own possibilities through countless individual perspectives. The mortality that characterizes individual existence connects to the same cyclical processes that govern the life cycles of stars, the evolution of galaxies, and the ongoing transformation of matter and energy throughout cosmic history. Death and birth, growth and decay, complexity and simplification, all emerge from the same fundamental dynamics that create temporal flow throughout the universe. This cosmic perspective on individual temporal experience provides profound comfort and meaning that extends far beyond personal concerns about aging, loss, and the apparent brevity of conscious existence. When viewed from the perspective of cosmic time, individual lifespans represent precious opportunities for the universe to experience itself through the unique vantage point of localized awareness. Each moment of conscious experience contributes something irreplaceable to the cosmic project of self-understanding, adding perspectives and insights that could not emerge through any other pathway. The temporal journey that begins with birth and continues through all the stages of development, maturity, and eventual dissolution represents a complete exploration of one possible configuration of cosmic consciousness. The scientific understanding of time reveals this journey to be not a race against limitation, but a participation in the fundamental creativity that drives all cosmic processes. The same forces that create supernovae, form planetary systems, and enable the emergence of life also ensure that individual consciousness can develop, flourish, and contribute its unique perspective to the ongoing evolution of universal awareness. The time that carries consciousness through its individual journey operates with perfect reliability, according to mathematical principles of extraordinary elegance and universality. The equations that describe relativistic space-time provide not merely technical tools for calculation, but windows into the deep harmony that underlies all temporal experience throughout the cosmos. This mathematical beauty reflects the profound order that characterizes natural law at every scale, from quantum mechanics to cosmology. The same geometric principles that determine planetary orbits also govern the curvature of space-time near massive objects. The same conservation laws that regulate chemical reactions also ensure the stability of atomic nuclei and the consistency of physical constants across cosmic time. The unity revealed by mathematical physics suggests that time itself is not an arbitrary feature imposed upon an otherwise timeless reality, but an essential aspect of the creative process through which the universe brings forth complexity, beauty, and consciousness from simpler initial conditions. Time provides the dimension within which all possibilities can be explored, all potentials can be actualized, and all forms of order and meaning can emerge. The forward direction of this temporal flow ensures that the exploration of possibilities proceeds in an orderly fashion, building complexity upon complexity, creating ever more sophisticated forms of organization and awareness. The irreversibility of time prevents the universe from simply oscillating between identical states, forcing it instead to continually discover new configurations of matter, energy, and information. This irreversible creativity makes possible not only the physical evolution of stars and galaxies, but the biological evolution of life forms and the cultural evolution of conscious societies. Each stage of development builds upon previous achievements, while opening new avenues for further exploration and growth. The arrow of time ensures that evolution is genuinely creative rather than merely repetitive. The human understanding of time represents one expression of this cosmic creativity, a way that the universe has come to comprehend its own temporal nature through the development of conscious beings capable of mathematical reasoning and scientific observation. The theories of relativity, the discoveries of quantum mechanics, the observations of cosmic expansion, all represent achievements of cosmic self-awareness operating through human consciousness. This perspective reveals scientific knowledge not as information gathered by external observers, but as expressions of the universe coming to know itself through the development of awareness within its own structure. The same cosmic forces that create stars and galaxies also create the brains that can understand stellar evolution and galactic dynamics. The same space-time geometry that governs temporal effects also makes possible the consciousness that can discover and appreciate these effects. The wonder that accompanies deep understanding of temporal physics reflects the universe's appreciation of its own elegant structure operating through individual human awareness. The beauty that mathematicians and physicists discover in the equations describing space-time geometry represents cosmic aesthetics expressing itself through localized consciousness capable of recognizing fundamental harmony. This recognition brings profound peace and fulfillment that transcends ordinary personal concerns. When individual consciousness aligns with cosmic processes through understanding, the apparent separation between self and universe dissolves into a more fundamental unity. The time that carries personal experience forward reveals itself to be the same temporal dimension that enables all cosmic creativity and evolution. The rest that comes with this understanding is deeper than sleep, more refreshing than any temporary relief from daily concerns. It is the peace of recognizing one's essential nature as an expression of the same creative intelligence that operates throughout the cosmos, subject to the same elegant laws that govern stellar birth and galactic evolution. And so, as we reach the end of our gentle journey through the physics of time, we find ourselves returned to where we began, to this quiet moment, this present instant where consciousness meets the flowing river of temporal experience. We have traveled together through the elegant mathematics of relativity, explored the measured reality of time dilation, and contemplated the exotic theoretical landscapes where space-time curves back upon itself in ways that challenge our deepest assumptions about causality and existence. And what emerges from this exploration is not the dramatic time travel of popular imagination, with its machines and paradoxes and desperate attempts to change the past. Instead, we discover something far more beautiful and profound, that time travel is not an escape from the present moment, but the very essence of what the present moment is. Every heartbeat carries us forward through the dimension of time. Every breath participates in the cosmic expansion that has been unfolding for nearly 14 billion years. Every moment of awareness represents the universe coming to know itself through the tender vehicle of conscious experience. The forward flow of time that carries you through this night, that will guide you gently toward tomorrow's awakening, operates according to the same elegant principles that govern the birth and death of stars, the formation of galaxies, and the ongoing creative evolution of the cosmos itself. You are not separate from these vast processes, but intimately woven into their unfolding patterns, a precious expression of the same cosmic intelligence that ignites nuclear fusion in stellar cores and guides the spiral dance of galaxy clusters across the expanding fabric of space. In the end, the deepest truth about time travel may be this: that we need not seek to violate the laws of physics or escape the natural flow of temporal experience to touch something eternal and profound. The present moment, with all its gentle impermanence and quiet beauty, already contains the entire history of cosmic evolution and the infinite potential of all futures yet to unfold. Rest now in this understanding, knowing that time itself holds you securely in its cosmic embrace, carrying you forward with the same loving care that guides planets in their orbits and nurtures the endless creativity of existence itself.